while this is going to be less coverage than I have online, it'll be a bit different, and it may be worthwhile recording. So the main things we've seen in the course of the Bootcamp as far as Java are twofold. One is expressions. Expressions compute values. They're like a formula in Excel. It adds this to this and divides by the third thing. That's what we call an expression cell. I call it informally a formula. And the point is that computes the value. So plus and out you get a value. 2.3 or whatever. I'm going to give you an orientation with respect to them. And then following that, I'm going to give you an orientation with respect to the other major type of thing we saw, which is a statement. A statement is something that tells Java to do something, change something. To take a variable and make it one bigger than its current value, or to call this other this piece of code. Tells it to send a message. That would be a variable. It's not computing a value. It's not getting a value at 0.34. It's instead telling it to accomplish something. And we'll see both of these. So the purpose of these expressions is to compute a value. Things like that could be of this form, or they could be integers like this, 2 and 1 and 10, true or false values. So when we had, is my current state such and such, it would return true or false. If we did random true or 0.4, it would return true or false as the condition. So when we compute these values, we can calculate something. So we can calculate values. There's a variety of ways we can do that. We can just give the value itself, just something like this. We could write down the status, we know it. Or we can do a comparison. A is greater than B. What sort of value do you think that returns? Is it something like 0.34, or is it a true or false, a Boolean? Yeah. Here we would commonly use multiplying times with either double precision value 0.3 or 0.5, or we use it with integer values. A little bit confusingly, someone else asked earlier, the question mark operator. Sometimes it's used as a colon operator. Sometimes it's used in one thing, sometimes it's used in a different context. Plus is used to add together two variables, but it's also used to put two strings together. So if you say UC plus LA, it will create the value that says UCLA, and this is just called a string in the second part. Call it a string, this is like the characteristic sequence of characters. You also see this thing A dot B. Like A dot, and then this B could be the name of so this might be main dot population size, for example. And what that's saying is find the population size inside of the same name. Name the population size. You can think of it as almost an apostrophe S, like main population. Okay. It could also be something like A dot, like main dot get connections number, and then begin parenthesis. It's a method we're calling it. It's a function we're calling it. You folks have seen this many, many times over. Question mark. We have a predicate. Is such and such equal to such and such? If so, A, otherwise B. We saw that many times with green or red based on whether I'm in a certain state. And so within our models, we will routinely use this to sort of pick one thing or another based on some outcome. Or you have random true, 0.5, male or female. What would that do? Can anyone tell me? Random true, 0.5, question mark, male or female. It would flip a coin. 50% probability is male, otherwise female. Yeah. So it hits either this or this depending if this is true. Just think of it as kind of like an if statement or if expression in Excel. You either have this or that depending on what this is. Okay. And then finally there'll be things like this, which actually change the value of let's see, this a plus plus. And the value of that is the current value of a, but then it changes a. It's incremental. It makes it one bigger than its current value after you've gotten the value from it. This multiplies a times 5 and gives you the resulting value. Okay. You've also, some of you have seen this, perhaps more so than you want, more so than you would ever desire. You've seen this, and this means and, logical and. It's true if and only if A and B are both true. A or B. If either of these is true, this whole thing is true, otherwise it's false. This means not A, so it means if A is true, this whole thing will be false. It's like almost minus of A, so 10 would turn to minus 10. Here, A being true means not A is false. A being false means not A is true. So we could have something like this. If A is greater than 0 and, x is greater than 0 and x is less than 500. If it's in that range. Here's another type of thing. Yeah. You want me to really tell you? So there's another option for what this means. And I believe that what that means is a bitwise and. So in other words, So it's something very different, and you'd use two of them. And this means or means either of these. So it could be, if it lies, basically this means if it lies between 0 and 500, it's indifferent. Right? This thing is basically taking, if you have you could think of A as, it's called an array, it's conceptually a vector, and it's taking the 21st element of it. Why 21st is 20 plus 1. So it's like a vector and holds maybe different values for different points here. 1.2, 0.4 here, minus 2.1. And it's looking up the 21st one of them. This is the 0 up here. This is the first. That's index 1. This is the second. Or this is an index 2. And it looks up the 20th. So it's 21st and this is the first. This is the third. Index 0, 1, 2, and 1, 2, whatever it is. Maybe 40 or something else. And you'll sometimes see that in models. It's less common that you'll see it, but if you're dealing with arrays, you'll see a lot. Here's a method call. This actually calls off to this. It actually calls this function. It's like sine of 90 degrees. It calls off and f does its work. It does its work. We don't have to be dealing with it. And it probably returns the value or it changes something. And then for strings, you can concatenate them with this. You could append them. So you see plus LA gives you that. These are some expressions. Now they're evaluated. Sometimes you'll see things like this. Whoa! What the heck does that mean? Well, the way in which you look at it is, okay, this is the first thing that does the value. And then it asks, okay, A, get me your connected agent. Get me who you're connected to. For person number I, where I starts at 0. Okay? Maybe I, the value of I maybe is 6. And so it'll say, okay, don't get me person 0, go here your agent. Boom, that gives me back a reference to some agent, some particular agent. It's mine, the person who I'm connected to, the third person I'm connected to, 0, 1, 2. Okay, and then it'll get their name. The name is John. Okay, so the name of the third person who I'm connected to is John. And then what's the length of that? Oh, 4. J-O-H-N. Okay, so that's a big expression. And it looks fearsome, but just read it piece by piece by piece. Don't get distracted by how long it is. This by itself, that's a reference to some particular agent. You ask, okay, that agent, who's their connected agent, number 2, so 0, 1, 2, the third connected agent, and then you get the name of that person, and you get that. Okay? And they're routinely strung together in this way. Now, it's good practice to keep it short, fairly short, but it's not infrequent to see things like this written down. You could think of it as the equivalent of writing down mathematical expression like, A over A plus C, times, C over C plus C or something like that. It's kind of a longer thing, but you can get used to kind of reading it. Just read it left to right. So this gets determined, and you get that. And this returns critically. This is a reference to agent. This calls this. It returns a reference to a particular agent. You can't change its agent. So it's getting an agent, and then we ask that agent's name, and then that name is something we ask its length. So this is along each point of this, when we have this returning a value. This is returning a value, A by itself, and that value is used to evaluate the next thing. That thing is now returning a value that's used for this thing. That agent's name is being asked, and that's returning values as length is being determined. So at each point along this way is kind of value from the last one and using it for this next thing. Using a value from having done that for this next quantity. Does that make sense? Yeah. Oh no, a good way to do this is to might be to break it on 2 separate lines. So you would say, you give this, so this is returning an agent. It's asking a third, say, if I is 2, 0, 1, 2, is returning a third connection. So you might say on one line, agent B equals A dot get connected agent of I, and then you can refer to B dot get name dot length. Like you give them a name. Give them a way of referring to them. So you could do that, and it would make it smaller. But I have to say, you do see things like this quite a bit. Could you write it another way? Yeah, you could. You could write in all sorts of different ways. It calls off. This is some package of work somebody wrote, probably over in St. Petersburg, and we're calling it. We're telling it, and this is routine. So it's a little bit like our daily lives. We depend on all these services to get our jobs done. We go to send a package with FedEx. We don't need to know how FedEx works. All we know is they give a guarantee. If I get it to the FedEx office by 10 a.m., it'll get delivered to San Francisco by 5 p.m. or whatever. I just go, and as long as I adhere to that, I don't have to worry about what the name of their driver is and what particular flight it goes on. They take care of it. And so it is with calling this thing. It's just a service. It's being done to you. So you call off, this is what it needs. This is what it needs to do the job. FedEx needs your money or account number, and they need, you get it to them by a certain time. This is what it needs to do its job. You give it that number, it will do its job. It will return the third agent, and it's up to it how it does it. And then, having gotten that back, then you could ask for the name from that, and it will go compute its name. And you don't have to worry about the vagaries of how it does it. It just gets its name, and then you can ask for the length of that name. And so basically a lot of it is kind of delegating to these methods, these so-called functions. Does that make sense? Yeah. Okay. Okay, so variable declaration. Right. You can give nice names to values. You can give values names. And it'll be something like this. I give this thing get. I give a value x to my current value of x, get x. I give a value name y to this get y. I give a value a name c to this value. So here's a thing that computes the value, and I'm just giving it a convenience name. There's nothing terribly special about that name. It's just a convenient name for me to call it something. So I give it a name. And we'll see this in code. Fortunately, in AnyLogic, you don't have to look at too much code like this. If you work with repass, this is like the name of the game. You're always looking at code like this. In AnyLogic, you occasionally ought to see it. And it's good to know what this means. It's giving a name for a value. That's all it is. It's referring to some value. Your get name, this is asking for my main class, like the main class for the model. So it's just giving it a nice name M so that we can use it without having to write this thing. Does that make sense? Yeah. So, we do that all the time. We give it a nice name, and then we can refer to C instead of having to write all this. Yeah. No, it's among other things, it's much crisper, it's much more transparent if we have short names, or if we have names for things that are meaningful, like X and Y, C and R for column and row. It's more meaningful if we have a good name for something than to write a long expression. Like if every time I have to see this, I have to write it out every time I read it, then it's cumbersome. I have to reason this through all again. Programmers are kind of lazy, and it may be a good way. They don't want to have to kind of think a lot all the time. And if I'm scattered every time I need C in the code, and maybe look at this, I need it here. If I put in this whole thing, that'd be horrible. I have to look at all this. I mean, you think this is bad. You have to look at all this code here, and it'll be here, and if I have to go fix this expression, I have to fix it several places. And so you instead just do it once and then you can do it many times. Yeah. Indeed. Oh, your thing was, yeah. That's just, in AnyLogic 7, it gives you a nice way to refer to this like a thing. That didn't exist in this version of it. Right, so it's careful. So you could type main.this. But the main thing they didn't want to have to call it every time it occurred. If they had that main automatically defined to them, they'd probably say main.main.main.. This is just, they want to give it a nice short name. And in general, names are not trivial in the sense that they just name a value, but choosing those names gives a lot of insight to someone reading what's going on here. There's a world of difference between reading, as we say, code that's written with care taken and with readers in mind, compared to stuff that's just pumped out by someone trying to get the job done. And in this case, they sort of name these X and Y so they don't have to have sort of a shorthand for this that's going to be familiar to readers. Is that helpful? Yeah. Okay. I think we'll limit that. Okay. Trying to go through here. Yeah. I don't think I need this. Okay. So the most common form of assignment is this one. So here what's going on is that whatever value B had is now becoming the value of A. A had that from the beginning, but now it's being overwritten by it. It's taking the value that B has. So maybe B has value 3.1415 times, and if A equals B means now A gets 3.141 plus 9 in it, okay? Or maybe B is pointing to John. It's John up there. It's pointing to John, and now A is going to point to John as well. They're both referring to John. You can refer to an object, sort of like an agent. John. Okay, they're both referring to John. Here, A is being incremented by whatever B is. So maybe B is 2. And now we're adding 2 to A. Yeah. And it's less cumbersome to look at for some people because you recognize, you can immediately see, oh, it's A that's being increased by this. So you don't have to say, oh, A there, oh, it's being increased by value. If you wrote A equals A plus B, and then so it's A on both sides, and then B, this kind of is crisp. It tells you it's being increased by 2. And you'll see this occasionally, less so in AnyLogic. This you'll see more. This means make A one bigger than it already was. And normally you see it on a line by itself. Sometimes you see it in expression. Ooh, that just gives me the willies. But that's one which is designed to allow it. And if that's the case, the value of it is A's original value, but then it increases it by 1. So these are just kind of shorthands of doing common things. They're not particularly sort of deep or anything. Yes. Oh, no, it these 2 pluses, it just means, if you just did 1 plus, it'd be looking for the next thing. It'd be looking, if it was A plus, it'd be looking, hey, what do I add it to? It's expecting something to add it to. A plus plus just means increase it by 1. By 1. Does that make sense? Just make it 1 bigger. Actually, change it. Changing the value of A. It's increasing it by 1. It's not that this is equal to A plus 1. If you wanted that, you do A plus 1. It's not just that this is a formula that returns 1 bigger than A. Actually, it changes the value of A. It modifies it. It says, whatever A is, make it 1 bigger. That's it. Oh, that's just a nice way of sort of, it's faking a fix. That's exactly what it is. It wouldn't write in a face, but it doesn't, Java doesn't allow face. You can't say, D'Angelo, is the name. You have to say D_Angelo. And so the underbar is kind of a full name space. Something like that. Okay? Is that helpful? Okay. Okay. Wish I had time. Okay, so variables hold values. And one type of value, ladies and gentlemen, is a reference. A reference to like a person. So M here, M could refer to a person. A could refer to a person. This could refer to names, which includes an array. This thing that is like a vector. And each element of the array could refer to a person, for example. And these are values. Hold the value that the saying John. Well, this one says John. This one says Mary. This one's pointing to Maine. And Maine is a population that has these little pieces in it. And you could say population, and refer to a particular population member is a person. So each of these elements of the population is a person, referring to a person. Particular person at that place in the population. Person number 1 in the population. Okay, now watch this. If I did this, if I said A dot mother equals M, you'll notice that mother, this A, whoever this person is, I think I said it was Mary. No, it was John. This is Mary. So here, call it Albert and Mary. Right? A for Albert, M for Mary. If you said A dot mother equals M, this right now is null. It's not pointing to anything. It's not. It can refer to a person, but it's not. It's no particular person. It's like the spot is not filled. You don't have anyone in that position.
anyone refer to, and then we assign to it. A dot mother equals M. This thing suddenly refers to this guy. Boom! Referring to that. Okay? Oh boy. So now it refers to this one. Both of them refer to John. Our president is John. And the head of our Rotary Club is John. They're the same person. Okay? Oh God. It has to be Mary. Sorry. Our president is Mary. Our mother is Mary. The head of the Rotary Club is Mary. Something like that. It's the same person, right? Why is Mary oh God. Oh, now I'm in a pickle. So we have a mother referring to a male. There's a bug in this program. Oh man. Okay. Thank you. Thank you. Okay. Now watch this. Oh boy, look at that. Now, a mother is equal to this dot get name. Okay, that's pointing to name. In any logic that we could look at name dot. This dot get name. Okay, points to name. And then it asks for the population and name. Okay, that's pointing to this guy. And then we ask for number 2. This one, that one. It starts at 0, that's 2. That one. It's this one here. So this guy now points to that. Hopefully that's a female. Because it's the mother. So this guy's mother is referring to this guy. So we can do that. We can say, hey, my mother is so-and-so. And in this case, you notice this thing here. Oh, you notice this thing is a square bracket. Remember we said to go into this, to find a certain number. This is number index 2012. So this guy refers to that. Does that make sense? Yeah. Yeah, it's getting a reference. Remember, all this returns values. So this is going to be assigned to a value. It's equal, and whatever's over here has got to be a value. So which value is this? We first deal with this. This is a value. What does this contain? It contains this, and we ask for a get name. Get name returns a value. It returns what sort of value? It's a reference to this guy. So now we've got this value. And then we say, okay, get its population. And we say dot population. It returns a value. It points to this thing. And from that value, we say index 2 interest. 0, 1, 2. Boom. That returns the value. This guy here. And this whole thing, therefore, is referring to this guy. The result of evaluating this expression, computing this formula, is a value. This value is pointing us out that is the value. And A's mother now gets that value and points to that same person. Does that make sense?
And here, what is the value for
This dot name? You mean in AnyLogic 7? Yes, it would be. AnyLogic 7 automatically provides a name for the result. Yeah, exactly. You could still do this if you want. It's still supported, but yeah, you could do this dot name dot population. Yep. Okay. Okay. That's ladies and gentlemen. You should have a certificate. You survived. I think everyone survived. So that's expressions. Those are Java expressions. So don't get flummoxed by those sort of things that we see. Hopefully when you read something like this, you'll have a degree of comfort. I mean, I find some things aesthetically unpleasant about this. I think it's counting that people know the C column. I think that's a bit of decimal. Give it a name of call or column so it's clear. But hopefully you won't be too frightened by this sort of stuff. This is just a name for whatever. It's just a name. What's this name thing? It's this thing, you have to tell what this thing is. This X is a double precision value. This Y is a double precision value. This T, it's a column, and it's an integer. 0, 1, 2, column 5. M is a reference to name. That's what that means. Yeah. Those spaces are ignored. They're meaningless in as much as it doesn't care about them, but we care about them as humans. We like to space, sometimes space things out so we see it clearly. Make it nicely formatted. That's important to us as humans. But as far as Java is concerned, it strips all the spaces away. It doesn't care about them. Unlike Python, for example, is a language where indenting is important. It takes indentation, and Java just ignores it. And this is a comment. It ignores this comment. Whatever vector class, it ignores. And the rest are wrong. And that's why it's important. We call it efficient because it's ignored. Yeah, that's part of it. That's true. A semicolon. They built it so that you could put two things in the same line, like if you wanted to, as long as they're separated by semicolons. But yeah, it would be nicer in some ways if it recognized, a separate line, so it's separate statements. Yeah, it'd be kind of nice. Okay, are people okay with what I've said? Yes. This is Java language. NetLogo is not in Java. NetLogo is in a sort of separate dialect of Logo. Yeah. And so that's a different language. Repass is in Java. ModGen is in C++, which is pretty close to. It's close in terms of the subset that it uses to Java, pretty close. So you would get a fair bit of gain. Java is the most widely used language in the world today. I'm pretty confident about saying it. It used to be Fortran. Python is giving a run for its money. But Java is extremely popular, and you would get a lot out of knowing it. Yeah. There's also a book that I refer to in my references that I've given you, called The Big Book of Simulation Modeling. It's specifically about AnyLogic, but it has a chapter, I think, on Java and Java Basics you might check out as well. So I just showed you one thing, and folks, I'm just shocked that you're willing to tolerate this. I recognize that I have an emotional interaction with these things, but I don't expect you to always tolerate these things. Okay. So what are methods? Methods are functions associated with the class. They do things, or they return a value, or they do both. They either perform an action or return a value. When we call them, say, compute for growing and compute for sine is this number. Or we say, the sine and cosine or what have you. Or we say, like, get me the connected agent number 3, and it will return a value for them. Or we'll say, like, send a message, and it will send a message off to this other agent. So it's printing values. It will change the state of the message. Okay. I don't know that we need methods are your friends in Java. Defining methods are the so-called functions. It's a really nice way to sort of wrap up functionality so you don't have to go look at it. We computer scientists, the software developers, we prefer not to look at complexity if you don't have to. And so we create a bunch of functions and we just call off for the function rather than putting everything together. A clutter is inimical to understanding. You want transparency, not clutter. This is horrible. Look at that. I mean, if my students did that, I would critique them. I would give them a good critique. Indeed. Yeah, this is quite write quite a bit of code. Generally, in good practice, we keep our methods to 10 lines or less. That's good practice. And I'm feeling I've been abusive to Ben in some of the code that I gave him, and I'm feeling I need to go improve it because it has such long blocks. This particular code, though, it's not horrible, but it's got all these constants in it. Oh man, refer to a variable, refer to a parameter. Don't just put constants. Anyway, I'll leave that. Okay, let's talk about statements then. Statements are commands. Java expressions compute value. Everything we were talking about earlier was computing a value. It gave back a reference, it gave back a number, or something like that. Java statements are sort of commands. They do something, they accomplish something, they change something. What can they change? They change the value of a variable. They return a value. They call a method. They perform a sequence of statements again and again and again in a loop. And you have to write a lot of expressions in AnyLogic. You have to write quite a few expressions. You've already done that as part of this course. And I admire your resilience. So you have to write a lot of these sort of things here and there. But you don't have to write quite as many statements. But you have to write some, like to print something out. Let's go in search of statements. Let's go check out some of these things for statements. SAR agent-based calibration. This thing we looked at earlier today. Let's check it out. Where's a statement? There's an expression. This rate. Why is that an expression? Because it returns a what? A value. It returns a value. This, by contrast, contains an expression, but also a statement. Statement sure sign, semicolon. What is the statement saying to do? It's saying do this. It's commanding it. Send a message, and it sends off this message infection. Sends off this message infection to a randomly chosen person. Okay. There are lots of these sort of things scattered around. These things we built yesterday, like with this sort of stuff. Note that this is an expression, but this is a statement. I'm printing out something saying I'm entering care. So the job in statements in life is to do something. They accomplish something. They change. What sort of statements are they? Yes, statements. Do this if this is true, otherwise do that. For statements. Do it again and again and again a certain number of times. While statements. As long as this thing is true, keep on doing it. Try catch finally. We'll try this out if there's a problem. Do this other thing. Okay? Throw indicates that there's a problem. An expression can be a statement. It's sort of most commonly it's a call to a function. It returns a value maybe, but it's called off to a function. It assigns one thing to another, which is overrode it. Composite blocks. Okay, so this is like a for statement. It loops this again and again. 100 times, from 1 to 100, up to 100, it executes the statement. This is what we call a loop. And I'll give you a confession. This is a proof. I was 8 years old. Computers were, microcomputers were new things upon the world. And I decided I was really interested. And I spent my summer camp programming a calculator. And I really wanted to graduate to a computer. I wanted to get my hands with things and be able to speak keyboards to go and spit out these things of paper. I went to a class. And it was a class, and it seemed that everyone else in the class was about 20 years older than me, maybe 4 years older than me. And I was there, but I got to touch the computers and got to solve them and program them. And then at one point the professor announced, or the teacher announced, this is the summer class, he said there's going to be an exam. I said, oh, I don't know what the exam is. But it's some sort of bad test, I guess, right? And so he said it's going to be a review test. Great. And he had been teaching us about all these things. Wild things. He knew that we'll do things. So he was walking up and down the aisle. We talked about variables. And he was walking up and asking questions of you and giving them answers. And then he walked up to me, and I'm trying to remember, he was on my right, so he like this. He said, suppose I wanted to go from 1 to 100 and to print out numbers for that. What would I use? I didn't say anything. He said, I'll give you a hint. And there's an L, 2 O's, and a P in there. And I said, cool? I kid you not, that's a true story. But I had one. So anyway, 100 times, this is called a loop. Loop. And here it goes, it starts at 0, the value of I starts at 0, it goes up until just before 100, it'll stop when it's 100 and won't do this. But for each I successively, it will, what does this do? It makes, increments by 1. So first it'll be 0, it will do this statement. And then it will make it 1 bigger, and I will be 1. It'll execute the statement. And it make it 1 bigger, it'll be 2. Execute the statement. Keep on doing that up until it makes it this, and then it'll test, is it less than 100? No. Not less than 100, then it will stop doing it. This is another one we've seen. We did this, actually, in our code. And this is where the objection was raised about the colon. And a fine objection at all, and it's one of sympathetic cases. What this does is for each agent in the collection do something. What is this collection? It might be the population. For every person in the population, maybe it's print out their name, or send them a message, or change their color, or whatever. So we loop over all the agents, and for each successive one, we call it A in turn. And we do something with that. And then we go to the next, and we call that A, and we do something with that. So it's just, whatever is given by the statement, it can refer to A as the person in the population. We'll go to each person in the population, calling them A, and it will do something with it. Does that make sense? Yeah, okay. Okay, if statement. Well, this is the loop structure. For this. Okay, here, this is horrible code. I mean, don't pay attention. This is more complicated than you should have to look at. This is not well written in code, but there's all these constants in it. But here we're starting with A equals 0, and we're incrementing A by the plus equals incremented by pi over 16. We're going until A is equal to 2 times pi. And then we're taking inside of that, for every one of those A's, we're doing B from 0 to 750 by adding 5 to it. And we're doing, speaking of nested loops, each iteration of outer loop, A being 0, A being math dot pi divided by 16, math divided by pi times 16 times 2. It'll be doing the full inner loop here. And for each of those, it'll be doing this. For all possible combinations of A and B, that's what I mean. We'll do that. Horrible. Well, that's pretty abusive. All the constants are not this one. Okay. If statement. If this is true, do this. Otherwise, do that. These do statements. These like send messages. And sometimes you read this out like this. And you only do this thing if this condition is true. You can have both, or you can just leave it like this. This does something. How is it different than question mark? The question mark operator, that thing we saw in the expressions, is kind of similar, but the question mark operator returns a value. This actually says this is true. If so, use this value. Otherwise, use that value. And these are expressions. Whereas here, this is doing something if this condition is true, or doing that if the condition is not true. Does that make sense? Maybe it's sending a message to the president, or sending a message to the Supreme Court of the U.S. Okay, there we go. Do while. Well, I don't think I have to go into that. While is kind of like loops. As long as the condition is true, keeps on doing it. Switches and cases I could go into, but I don't think you really need to know this. Basically, it can handle a bunch of cases. This case do that. That case do this. Kind of nice way of listening. Okay. I'm not sure you need to know much else. I mean, if you put things inside of these curly brackets, it just means treat them all as a single statement. So everything inside the curly brackets is treated as a statement. Variable declarations, you've seen that, and then expressions. Here, it's calling off to the uniform and assigning it to that. That's a expression, but it's also a formal statement. It just computes this and assigns it to the value of the variable held by heading. Okay, I don't think you need to know about exceptions to use Java. Ladies and gentlemen, I think you basically have gotten most of what you need to know about Java. Any questions? Sorry to inflict this up on that one. Yeah. Yeah. Yep. Oh, sorry. This guy here? Yeah. Mm-hmm. Okay. Okay. So agent is each person population. Let's do this. This is let's go do this up. Okay. So it's I'm going to open up a model and here we go. So here's our continuous time. Oh no, not that one. Sorry. I wanted this one. Resource constraints with deliberate problem. That was the one I wanted. Sorry. So what we wanted is with resource constraints. Okay. Come on. Give me any of them is fine actually. Okay, fine. So I think this is the one I introduced problems into before, and I think I fixed them. So we're fine. Okay. So here, watch this. We have main here, and main contains a population. This is a model I gave to you. Here, let's put into main on startup for person P in population, trace ln, person. So my name is P. So what that will do is, for every person in the population, it's successively in turn, we'll call them P and we'll print out their name. Yeah. That's this class. That's this thing that we call it's personhood. And what this is saying is this variable P, it's a reference to a person. It refers to a person. Just like before in that last thing we said that you can have a reference to this person or to this person. Remember, their mother is this person. That's what that's saying. It says make this a reference to each successive person in the population. They're going to refer to John first, and then they're going to print out John's name. Then they're going to refer to Mary next. They're going to print out Mary's name. And then they're going to refer to Sue next and print out Sue's name. Does that make sense? That's right. That's exactly right. Yeah. And in fact, in this case, we can even just say it's an agent. It's just some generic agent in the population. It could be a person. It could be an elephant. It could be an aardvark. And for any of those, we will print out the population. There we go. A thing of beauty. Have you seen a better pool in your life? So there you go. Is that helpful? Yeah. So where did I put that, by the way? I put it here in main in the startup. So when this runs, this thing will happen. That can be useful. I could go record things to a database. I could go take the average. I could identify the median income, for those people. I could count the number of people with some characteristic if I didn't want to do it in the statistics area. Can I show you something secretly? Watch this. I'm gonna show you a secret that's been. Let's go. I actually, to show you the secret, I need to show you a model where we used a statistic. Okay. Here's a model
where I think we define a statistic. I hope we did. And let's go look in the population. Oh, we have no statistics here. Okay, great. Let's go define a statistic here. I'll count the number of pregnant women in this population. Watch this. This is our open population model, and I'm going into that. I'm going to define a statistic. Count pregnant, okay? Count pregnancies. And it's going to be a count of people. I don't know why this thing is walking this way. It's going to be a count of people who are pregnant, okay? Let's go do that. So it's going to count item dot. Notice this item. This is a reference to the current person, right? And I think it's called pregnancy state chart. That's what it's called. Pregnancy state. Oh, pregnant. Pregnancy state chart dot is state active, and then I'm going to ask person dot pregnant. I think that's what it's called. Pregnant. There we go. Okay. Now watch this. Okay, good. We're a happy camper. Is this an expression or is it a statement? It's an expression. It's computing a true or false. That's why it's is state active. First we ask, okay, hey, you person in the population, give me your pregnancy state chart, reference to that. It says, yes, okay, I'll give it to you. Here's the reference to my pregnancy state chart. And then we ask the pregnancy state chart, hey, are you in this certain active state? And it says yes or no. But watch this. This is the secret. This, ladies and gentlemen, is the secret that I wish to confer to you. Control J here. It actually shows me the code for this. And look what lies before us. An enigma, a mystery, a riddle that I hope I've decoded for you. Here we have this is just a method. And notice this for loop. What is it doing? All it's doing is over each person in the population is calling the item in turn, and it's determining if this thing is true. This is just the thing we wrote. And if it's true, it increments some value. And then it returns that value. Ladies and gentlemen, you should be able to feel some measure of confidence that you understand this with the pieces I told you. It starts with this nice little name for a value that starts with 0. It goes through each person in the population. Notice these curly brackets are a bit messy, but not. It determines for each person in the population it sees if this thing is true. If so, it increments the value. Otherwise, it doesn't increment it. So what it does is it goes through each person in the population, counts the number of people for which this is true, and returns that value. That's what a statistic is. It's just that you don't have to write this code like you would in Bootcamp. It writes it for you. Is that helpful? Okay. Any questions before I leave the topic of Java? You don't have to know all of Java. I wouldn't go pick up Kay Horstman's book on Java, the programming language, unless you're really hoping to learn a lot. It's actually a fairly small subset that you would have to use to do most AnyLogic, to do most AnyLogic things. Okay? Any questions?
And that's my question.
Yes. The big book is elation. That's most of small subsets, or by reviewing my series online. I've tutorials. I've set about 8 tutorials online on systematic regression, but I've given you the most important ones today. And I think if you were to really study what I told you today, you'd get 80%. Okay. Any questions? That's a good question. It is based on AnyLogic 6, but it's really not material for the issue of Java. In other words, that chapter, you would get equal value of it if it was written for AnyLogic 7, I think. For the most part, AnyLogic 6 and AnyLogic 7 have certain areas where they are different, but it's fairly localized. I mean, do you want... So briefly, AnyLogic 7 and AnyLogic 6 differ in a couple areas. One area is that it's much easier to do, or it's easier to do hybrid modeling with discrete event simulation now. That's one area. A second area where it's changed is is an environment used to be a separate object, now it's combined into a person for they tried to do that person plus A. A third area where it's different is that now they have connections explicitly within a person. You have these connections here, and you can actually communicate across them explicitly. You can show them or not. They're explicitly shown, and you can have very easily, social connections, and then have a separate one for sexual connections, another one for needle-sharing connections, different classes of connections, family versus colleagues. And that's new to AnyLogic 7. AnyLogic 7 also has some improvements for trying to think what it is. I think it's right. There's some improvements in the UI in terms of kind of how it presents these. Instead of having tabs, you can just scroll down. They have option lists. These option lists were not in AnyLogic 6. So this whole thing with having males and females or different ethnicities, that wasn't there. And there's a couple other areas like that, but it's pretty localized differences. Kurt and Winchell, do you want to comment on that at all? AnyLogic 6 or 7, big differences? Yeah. 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 Yeah, and like this connection thing, I told them in help, we need to be able to distinguish multiple networks of people, and right now I have to write custom code for the AnyLogic 6 to distinguish sexual from social connections or what have you. I want different ones captured, and they did that. They're also inserting population pyramids and a bunch of other sort of support for features in the next few versions. The health space is one we're helping them to kind of recognize the need for it that it is missing. Yeah. 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 For these connections, you're saying? Yeah, but you don't have to declare sort of a whole data set for it. That's correct. Yeah. But you do have to sort of take the people in mind. Yeah. Yeah. Two steps forward, one step backward. Yeah, Winslow? That's right. That's right. Yeah, that's right. Also, you can create like an agent for doctor and then have specialized versions of that for cardiologists and pulmonologists and surgeon and internal medicine doc, orthopod, etc. And those are all sort of specialized versions of it that get all the attributes of the general doctor and ahead of time. You don't have to define them many times. So it's called subclassing. No. Mm. Okay. Uh-huh. Okay, that's helpful. Any other questions before we move on? Okay.